Okay, so like I was saying, this is backend lecture number 1. So we'll be covering the basics of kind of REST design, API design, kind of the fundamentals of how websites talk to each other. So a little bit of context on that. Ultimately, when we talk about building a backend, what we're basically saying is, okay, there are 2 parts to a website. There's what the user sees, what they interact with, the buttons they click. That's all JavaScript, HTML, CSS. You know, it involves how does the user interact with the screen, with the website. Now, the question of what happens when they click those buttons, what happens when they give us data, what happens to make their user experience as fulfilling as possible, that's the back end. So front end is kind of what we present, and back end is kind of what we're actually doing. So for example, think of Amazon. So if you go onto Amazon's website and you type in, from the very moment you type in your first query to their search bar, or even from the first moment you load their website, their front end is displaying the various products you see, but it's their back end that's getting those products, getting the reviews, getting the stars, running the algorithm that says, okay, how do we order these products? What priority do we put them in? That's where you hear about interfaces with machine learning, AI, voice controls, all of those kinds of technologies that we actually, that make a website functional. That's all on the back end. Okay, that's kind of a general overview of the importance of a back end. Does anyone have any questions so far? Okay, silence is loud, tough crowd. Let's go ahead and get started with the presentation then. Okay, so I do not have slides today, but I am hoping to kind of do a like lab component to today's presentation. So as best as you can, try to follow along, and we'll take pauses to make sure that everybody is able to keep up. Before we do that, can I get a quick like yes or no reaction on whether you guys have a bash or a terminal installed, or ZSH is fine too? Just give me a yes reaction or a no reaction in the chat or on your screen or whatever. Okay, so of the people that are interacting, I'm seeing yes. Okay, so then I'm gonna go ahead and say that it should be pretty easy for everyone to follow along for most of the presentation. And again, we will stop and I will check in to make sure everyone's keeping up. Okay, so REST, HTTP, and Postman. So to kind of break this down, actually this should be called HTTP, REST, and Postman in order of the most fundamental to the most practical. So HTTP defines how we make requests. REST defines how we choose to organize those requests. And Postman is how we test those requests. So I mean, all of these are important, but in ranking order of what hopefully you can leave today with, it's HTTP, REST, and Postman. All right, this is the Postman logo for reference. All righty. Does anyone have any questions so far? Feel free to put it in the chat. All right, moving right along. Okay, this is not relevant. Ignore that, please. Okay, so HTTP methods. So going back to the example about Amazon. Let's think about how does Amazon, the front end, communicate with the back end? How does Amazon send information over the internet? Or even at a more fundamental level, what is the internet? In a very simple reductionist way, the internet is kind of just collections of data being sent back and forth, right? So the question is, how do we send data back and forth? And ultimately, it's those connections that are what make the internet what it is, right? So the key, it's HTTP. HTTP stands for Hypertext Transfer Protocol. And basically what that means is your browser and the entire internet, your internet service provider, your browser, your computer, they all interface with this very specific protocol called HTTP. And so to understand how we have to build our websites to be able to interact with other websites on the internet, to interact with users, to interact with search engines, to interact with other websites who might want our data, we first have to understand HTTP requests. So what is a request? A request consists of several parts that define what kind of request we're making, where we're making it, how to make it, if we're allowed to make it, and kind of a catch-all field called data. And data is actually the payload of what we send back and forth. So when we're making requests, sometimes we make empty requests and get data back. Sometimes we send data to the server and get data back. Sometimes we send data and just get a confirmation back. It's completely up to us and our use cases and how we interface with other websites and their use cases on what kind of methods and what kind of data we're getting and returning. So there are a lot of different types of requests, but the three biggest, most common ones are get, post, and put. And each of these serves a unique purpose, which I will go into more detail about. But what it's important to know is that technically, you can make any request do anything you want. But in order to keep your code clean, organized, readable, and most importantly, interoperable, we want to stick to the method definitions that are given to us. We want to keep a sense of consistency between one of thousands of communities on the internet. Okay, so let's start with probably the most fundamental one, that is get. Get essentially says, okay, please get this data. I know, shocking, really, but it's the most basic request. All that it is you saying, please make a get request at this URL. You don't need data, you don't need parameters, you don't need authorization. Just please get this data from this place. That's a get request. A post request, on the other hand, is us sending data. Please post this data. So we would include a post request to a location with a payload. And that payload is the data that we're sending to the server. The final bigger one is put. Put is basically how we update data. We say, okay, please make a put request to this location to update this piece of data with the new data that I'm carrying. Okay, that was a lot. Let's take a moment to let that one sink in. Does anyone have any questions so far? Please feel free to ask. Today's presentation is a lot of talking. So if you don't ask questions, it'll get boring real quick. Can you repeat the idea of what post was again? Yes, of course. So get gets data from the server. The server is sending us data. Post is we send the server data. So let's say, for example, I have a database on my backend, okay? Let's say somebody makes a GET request to me. This is what you guys will be doing in this part of the course. I'll be teaching you how to build these APIs with these requests so that when people make requests to you, you know how to respond. So if somebody's making a GET request to me, they're saying, can I please get this data? So I'm going to send them the data. If they're saying, making a post request to me, then they would send me data and I would store that data. Is that clearer? So they're posting data to me. But when they make a GET request, they're getting data from me. Whereas if I make a GET request, I'm getting data. If I make a post request, I'm posting data. So these requests are from the perspective of the user. What is the user doing? Is the user getting data? Is the user posting data? What is the difference between post and put? So post is like let's imagine like you have a flyer, right? You post it up on the wall, like, okay, here's a brand new thing for everyone to look at. Then let's say, okay, I got the date wrong. Let's put a new date. So post adds a whole new data item, like a whole new entry essentially, and put can update that same item. So if you say, like, let's say you make an account on a website and you realize, oh my God, I hate my username, which I'm sure everybody is familiar with that trial and tribulation. When you make an account, you post that account data to the website's backend. And when you change your username, you put a new username into your account data. Does that make sense? Okay, excellent. All right, then let's move along. Also, this says the most commonly used ones are delete. Delete basically is self-explanatory in that it deletes data. You make a request to say, oh, okay, please delete data at this location. I'm not going to go into that. What do I mean by payload? So a payload is basically data that's attached to your request. And we'll see a lot of examples of this. Today's goal is to get you to understand how we make HTTP requests. I don't expect you guys to get it off the bat. But to summarize, I'll stop using the word payload. That can be confusing. It's essentially data that we attach to our request. Okay, so this is kind of like a graphical interpretation. So we have a GET request to this URL by this protocol, HTTP. We have the host from which we made the request. We have a bunch of information that you guys don't need to know, or maybe you will eventually, but certainly not for this class and usually not ever. And then you have your body, your data down here. So here we have book ID is this number, author is this person. So this is our data. This is our payload. Here's our request. Here's our payload. You can think of it like a letter, right? When you write a letter, you put an address at the top and you put a return address, you put the to address, you put who's it from, right? That's all metadata about your letter. And then you write your body of the letter. And that's where the real meat of it is, right? Okay. Are there any other questions before we move along? I highly suggest you ask because it will increase in complexity from here. No? No one? Alrighty then. Let's move on. Okay, so kind of what I just went over. We have our request line, our header, which is kind of all this information. So one example of information that's stored here is when you log in somewhere, essentially what happens is the server issues you a token that says, okay, this person is now allowed to access this data. So that's a field in the header. You would have user token is this, so that when you make requests, your request can be authorized. And I'll show you more examples of this as we go on. And then we have our body. That's where we keep all of our, my old English teacher used to say meat and potatoes. So that's where we keep our meat and potatoes. That's what we really care about. The data is what we're trying to move back and forth. And so that's where the majority of our purpose is, getting data from the body. Okay. So we just talked about how to make an HTTP request. Now I'm going to talk about HTTP responses. So if any of you are in healthy relationships, you know that communication is a two-way street. Same with HTTP principles. If you make a request, you should be expecting a response. And when we design servers, it's our job to send responses when we get requests. So the anatomy of a response is slightly different than that of a request. A request says, okay, here's what I want you to do. I either want you to get, post, put, whatever. Though, by the way, sorry, side note, those are called HTTP verbs. So get, put, post, those are HTTP verbs. So I'm going to use that from here on out. But you have your HTTP verb, right, which defines what you want. It says, okay, I'm making a request to this location with these headers and this data or not. But basically, they are defining what they want. Our response is slightly different. It's only responding to the question it was asked, right? So it doesn't matter where the request was made because we define where it responds from. It doesn't matter the authorization. It doesn't matter all that stuff. It basically is the server's way of saying what happened to your request. And if it's successful, why was it successful? And like, here's the stuff you wanted. So we get, was it successful? If not, what went wrong? And if yes, successful, here's what you requested. So here are some of the most common codes. The way it works is that the very first digit here is indicative of kind of whether it went wrong or not. And then the last digit here is, or the last two digits really, are indicative of kind of either where it went wrong or what kind of correct it did. So for example, if I make a GET request, right? Let's say you say, okay, please get this list from the server. And I say, okay, I've received your GET request. Now I say, okay, we have this list and I can send it back to you. So I'm going to send response code 200. And in the body, I'm going to say, here is the data you requested. If, for example, somebody put a post request like, okay, please add this item to the list. I'd say, okay, I received your post request. I'm going to add this item to the list. Look at that, it added successfully. I'm going to send you a 201 request empty. I don't need to send anything back except an acknowledgement that I received your request, executed it properly, and finished it as intended. Few other ones, you really don't have to worry about 300 or 500 or 100. Those are pretty specific and you can look them up at any time. So I'm not going to go into them. The most frustrating ones are 400. So 400 means screw you, your request is no good here. Either 401 means unauthorized, 403 means forbidden, 404 means not found. I'm sure you guys all know that one. 418, random. And then 500 means server error, which is also frustrating because it's completely unspecific. Okay, are there any questions about that? That was also a lot of information, either about responses or codes or how we encode data in codes. We'll see a lot of examples of this too. Okay, no questions. Okay, I move forward cautious and not optimistic, but I move forward anyways. All right. All right. We are now going to move into the interactive portion of our presentation. So I encourage you to follow along. I obviously can't make you, but it would be dope if you did, I guess. Yeah, okay. So now we're going to make our own requests manually. So everybody take a minute and open a terminal session, just a plain vanilla terminal session. This can either be Bash, it can be ZSH, it can be most Linux shells support what we're about to do. So go ahead and pull that up. I will wait 2 minutes while everybody gets that ready. For the people that just came in, we are currently setting up our terminals or pulling them up so we can do some fun interactive stuff. Please interact with me. I'm so lonely. Just acknowledge that I exist. Send something in the chat, hello, or a reaction. Okay. I don't know if this person meant to, but they put a yes. I appreciate that. Oh, 2 people. I appreciate. Oh, a thumbs up. I appreciate that. Thank you. I exist. Wow. I love that. Why does 418 exist? Simply because code monkeys are jokesters and they do funny things just for the fun of it. Is PowerShell going to work? Let me check for you. I do not use Windows, but we can, of course, check. Oh, hello. Let's see. It doesn't seem promising, I'm going to be honest with you, but I'm also going to be doing this with you. So if you guys don't want to, you can always watch my screen. I'm going to share a desktop now. If something weird pops up, just pretend it didn't happen. We'll mutually pretend it didn't happen. Okay. Also, you guys are stuck with me for the next 3 lectures. So either start interacting now or I get more and more angsty every lecture. All right. So let me also pull up the reading so we have it side by side. Okay, can everyone see well? All right, I can assume you guys can see. So I'm just going to move right along. All right. So basically, the point of this exercise, I'll just tell you in advance, is that I want you to see that a request has nothing to do with a website. A request is strictly how we interact with the internet. A website is a byproduct of that interaction, but the requests we make are not necessarily connected to receiving a web page. We can get anything back, okay? So right now we'll be covering curl, and basically curl is the most simple possible way of making a request. It's basically just your computer saying, please, for the love of God, send me this information, the most bare bones text format. So let's look at an example. So this is an API which promises to return data to me about the Pokemon Ditto. And I'll go more into the parts of this URL that make it an API, or ways that I know that it's an API. But for right now, let's just everybody take this command, go ahead and copy it into your terminal and just hit enter. All right, that looks disgusting. But essentially, this is a ton of data. Let's look a little more closely. We have here a little bracket, which if you're in 61A signals possibly a dictionary type data structure. And we have abilities, and it lists our abilities. Oh, hello. It lists our abilities. It has Limber, which links to another database of just abilities. It has experience levels that you would need to get there. Basically, my request said, please get me all the data you have on the Pokemon Ditto, right? And we returned to me this entire enormously large data dump. Okay, now as a thought exercise, what happens, what do we think will happen if I put this request into my browser? It returns exactly the same data as pure data. This is not a web page. This is simply the browser rendering pure data. And so what I want you to kind of realize is that your browser is just making fancy requests and rendering what it gets back. It's not actually requiring any sort of certain data or web page to be returned. It's simply making the request that you tell it to make. So to kind of make that clear, let's look at this. If I go to example.com, for example, right? Here we have a little example domain, right? It's a web page. It rendered as a web page, right? What do we think will happen if I put curl in? I quite literally get a plain text HTML web page. Wait, can you guys see this? Okay, that was weird. It said participants cannot see your screen, so I got scared. Can you guys see like both windows? Okay, excellent, great. Back to the point. So quite literally, it returned an HTML page. And if this was in the browser, my browser knows how to read this and render it nicely, but at the fundamental level, it's just receiving a file. So to kind of hit on the point I hope I've been hitting on sufficiently, a request is just data that's sent back and forth. Your browser, your terminal, they're just making the same types of requests. What they do with that request varies, but ultimately the entire internet is just these requests sent back and forth. And knowing that, we can leverage that into making our own requests and our own desires for whatever website we're trying to design. Okay, I think this is a good place to pause and breathe. Does anyone have any questions? Okay, so okay, so how is the terminal allowed to get that data? Where is it looking when making these requests? So we will learn how the terminal is getting that data. Essentially, it's not so much that the terminal is getting that data as it is the terminal is requesting that data from the server at example.com. Actually, I don't know. I would probably guess that maybe only like 40% of you actually watched all the Internet 101 videos. So I'm just going to do a quick review of how it works. But essentially, a URL is just an alias to a server. So a URL maps to a server because your ISP says it does. So basically what I'm saying is, curl, please make a GET request, that's implied, sorry, to this server. And the server is choosing whether or not to send me that data. So it's not so much that the terminal is getting that data as it is it's displaying the data that the server sent me. Is that a little bit clearer? Okay. Okay, so now another question. Does curl get CSS and JavaScript in a different form? It's certainly a little complicated. We can look at a more advanced website. Let's just see. Let's just go crazy with it. See what happens, right? This document has moved. I don't know what that means. Okay, so clearly we have quite a bit of things here. If I were to guess, the reality is you actually don't need to know this. Like the way we design websites is this is all abstracted away. But if I were to guess, then I would guess that it just inserts all of the data into a single file and sends that file. Is that clear? Actually, just don't worry about that. You can look it up. I wouldn't know off the top of my head because it's largely irrelevant. Okay, I think Kelly had a question. Kelly, did you want to ask your question?
No, you kind of answered it already. Yeah, thanks.
Okay, excellent. Sorry, excuse me for 1 second. Feel free to try this example, type in your favorite websites. I'm just gonna grab some water real quick. All right, so I know everyone probably doesn't feel comfortable with this, but does anyone have any more questions before I move on? Okay, then. This is going a little slower than I thought. Sorry about that, guys. I know this is probably really boring. It's all just talking. Okay, I'm gonna go over this kind of fast. You can always go back and read this. I'm essentially just reading through the lesson plan that I have here. So if you have any questions, please feel free to ask. But let's look at the request we just made. So we said, okay, curl to this URL, right? And basically what that says is there's an implied get here, which I didn't show, but this is a get request. So when we look at a request is to a location. So the question is, how do we design or map our website to layout locations where people can make requests? And then how do we, depending on that location, send the data that's appropriate? So here I made it to this location. So let's take a look at this location. Let's look a little into the anatomy of how this person designed their API. And what you'll realize is that API development is completely dependent on the designer. It is your design choice on how you want to lay out your API, on how you want to organize it. And on the flip side, that's why it's so important to have clear documentation, a clear way for people to understand how to access your website. So if we go to this API's kind of main page, we have this kind of extensive documentation for how to access their API, right? So this is just one example, but if you go to their documentation, which is here, it will tell you how to use it. Okay, so let's look at this location. So the first part is HTTPS : // that basically just specifies the protocol. That basically says I'm making an HTTP request, not an IPFS request or anything like that. You guys will not encounter that. I can almost guarantee it. So we can gloss over that. So now we have the root domain. So the domain name is basically a way of, instead of having to type in a sequence of random numbers that maps to a specific server, we alias those numbers with a domain name. So your ISP, essentially internet service provider, essentially keeps a list of all the domain names and all the server addresses, and it maps every server address to a domain name so that we don't have to worry about that. So this is basically just saying, here is the actual server to which I want you to make the request. Okay. Then we have our actual API. So when you think about a website, right? Let's look at the Web at Berkeley website. So here, right, we have kind of this like nice front page, pretty front page. And then if we go to a different page, right, we see this /about. Basically, right, if you think of how your computer works, if you've ever seen a file path, we basically write slashes to subfolders, right? So we have our top level folder, and then we slash into a smaller folder, smaller folder, smaller folder. And that specifies where exactly we're going. A website works similarly. We have a slash to specify, okay, in this top level location, please go to this sublocation. Or in this case, please go to this sublocation. Or I don't know if we have second order URLs here. Probably not, to be honest with you, but oh, maybe he blocked me, who knows? Oh, hold on, I can't see. Gosh. Okay, so basically, when we say /API, essentially, right, we talked about how a server can either send data or a web page, right, largely. So usually /API means that it's going to send back data. So if I were a web page interacting with another web page and I only wanted data back, I didn't want an HTML page back, I would want to make a request to their API. I would not want to make a request to their top level domain because I would get HTML files back. And what am I supposed to do with that? I just want pure data. That's kind of the advantage of an API is it's a way to access data purely instead of getting all the fluff of having to open a web page and sift through a web page for information. It's a programmatic way to access what the website has to offer. So basically that's stored at /API, right? Then we have probably the most critical part of going back to when we put slashes, we're essentially specifying a location. So we're saying, okay, inside the API, right? Inside version 2 of this API of this website, please look at your Pokemon and return this Pokemon. So each level of the URL is a more specific data that we're trying to access, right? And the reality of this is every website is different. It is completely up to the designer, i.e. you, how you want to lay out your website. And it's your job to communicate to the user how they can access what they need from your website, because everyone will be different. So it's important to keep aware of how to make websites as intuitive as possible. Okay, so quick review. We have our protocol, right? We're making an HTTP request. The S just stands for secure. Then we have our server. We have our API because we want data, not a web page. Then we have what kind of data? We want Pokemon and we want the Pokemon Ditto. Okay. One more information dump down. Do we have any questions? Okay, yes, Kelly, go ahead.
So when you mean the API part sends pure data back by pure data, do you mean all that text on your terminal?
Yeah, so if we scroll back, right, you see how this is an HTML document, right?
Mm-hmm.
It's basically like telling the web page, okay, please render this data in HTML, like please actually render this web page. Whereas here, right, do you see how it's not HTML? It's purely information. Like it's just data inside of a data structure that we can access, right? So this is an API call in the traditional sense, and this is just a request for a specific page. Does that make sense?
Yes. Yeah.
Okay, does anyone else have any questions about that? Okay. Anybody else have any questions about anything? All right, moving right along then. So here's another example of an HTTP REST. Actually, this one, it'll probably be a little bit easier to see. So here, this particular website has chosen to make it so that they don't have any rendering. So their API is just the top level, okay? So if I make this request, I get this data back, right? So here I get just data. I'm not getting a web page, I'm getting just data, right? So we could have it where, let's say I'm the designer and I say, okay, I want to make it so that the user can specify a maximum value. Now, we could do it where we add another slash and say, okay, make the maximum value 10, right? But then if you think about it, right, if we want the user to have precise control over any given value they want, then we would have to have, like, let's say we have up to 1 million data items. we'd have to have up to 1 million different locations. We'd have to have 1, 2, 10, 500, 14, whatever, you know? So before the advent of modern web development technologies, that would have been a literal nightmare. That would have been quite irritating, quite unwieldy. It would have been very difficult. So instead, we have what are called query parameters. And query parameters are essentially a way to pass special information about the request that doesn't quite fit into the normal HTTP request like fields. So I showed you earlier, our request structure is pretty rigid. It's well-defined protocol. So query parameters give us more flexibility, and they're specified like this. Basically, we have, okay, make a request here. And then in that request, right, that's what this little question mark operator does. Put in these key value pairs. Put in the minimum as 1 and put in the maximum as 100. And here we could technically have as many parameters as we want. If they had a parameter that was, let's say, like median, or make it so that the distribution is centered around mean of 10 or whatever, you know, we can essentially have an extensible list of parameters that we want to pass. The downside is that, number one, URLs can get very unwieldy that way. And number two, the server can only process parameters which it knows how to use. So here, I looked this up beforehand, and the website told me you can pass a minimum key value. If I put this as minimum, it wouldn't work because the server doesn't know how to process that particular key. So that's another my lobbying for proper documentation and smarter design. So here we're kind of balancing user control with like programmatic difficulty, like programmatic complexity. So you want to ease your workload to the maximum possible while also easing the users. So let's go ahead and make this request. So here you can see our random number was quite large, but if we make this one, right? Please don't put the get here. That's my mistake. Just to omit that when you make your requests. Oh, hold on. Oh, that did not do what it was supposed to do. Hold on. Okay. 1 second. Make sure to copy the text and not the block. Otherwise, your terminal will do what mine just did, which is really irritating. Okay, I make this request. Now I see that my random is 25, right? Clearly, that's not just random chance. Like I can make this request again and again, and it will never be more than 100 because I've told it not to be. All right, are there any questions about that? Anyone at all? All right then, moving right along. So we talked a lot about how we transfer data back and forth over the internet. And in order to do that, right, if you think of it, there are millions, if not billions of websites online, which we use to, actually, you know what, let's take a 5-minute break. I think it's been a lot of talking. So I will give everybody like 5 minutes to recuperate. Let's meet back at 7:40. I have resumed the recording. So let's just finish off with the lecture. Okay, so back to what we were talking about. So servers send data back and forth all the time. Millions of websites are sending data over hundreds of millions of connections at a time. And so in working with all that data between websites, between designers, between companies, all types of people use the internet. And so it's absolutely critical to keeping the internet interoperable without too much headache, that we use some kind of standardized way to exchange data. So we want some kind of assurance that if I make this request for data, I should expect to get back a certain type of data. It should be what we call in computer science, it should be deterministic. So every time I try the same outcome, I should get, or every time I give the same input, I should get the same output. So for us, for our purposes, there are a few different data types out there, and we can learn how to interact between them. But the main one, and by far the most dominant one, is JSON. So JSON stands for JavaScript Object Notation. This is absolutely critical. JSON has nothing to do with JavaScript. It is just a name. Every language can parse JSON. Every language can use JSON as data transfer. So if it helps, just think of it as JSON. Don't think of it as JavaScript object notation. It's just a way to store data. So, all right, let's take a look at an example of JSON. So just based on a quick poll, how many of you have taken 61A and or know what a dictionary is? Okay, so most of you. So JSON is kind of like a janky dictionary. It's basically just a set of key value pairs. So going back to our other example, right? We have the status, success. This is not the same as an HTTP response, by the way. This is just their choice to tell you that the status was a success. Then we have the parameters we sent. They're just acknowledging that we sent them. Then we have our actual data. And then this is just my extra example. This wouldn't have been in your output, but we can basically nest JSON. So here we have a large JSON object containing a smaller JSON object. We can also do lists. So we could have gotten something like a list of 10 random numbers, right? It's essentially a dictionary. It's a way to store data in a organized format, accessible format, so that we can see what we need. So the object has keys that map to values. So if we were to say send a request from our website to another website, we would get back, and we can expect JSON back, then we can use language tools like Python dictionaries or whatever to parse JSON into some sort of native data structure and then access the field that we need programmatically, right? So it's a very efficient way of exchanging data, a very like basically rigid. It keeps everything standardized, but it's actually not rigid. It's actually very flexible. So we can basically put anything we want into the key field. We can access it, and then we can put whatever we want, right? Okay, so here is an example of a GET request. So this GET request is saying, okay, I made a GET request. Here is the response. So going back, we have our 200 status, right? That means, okay, we have our headers that we sent, right? Which I told you, don't worry about it. We have our URL. This is the same as the last example. We have a get method, right? And then we have our data. So here we have, right, this big JSON, right? Then we have this data returning this list of JSON. So we have JSON containing JSON, containing a list, containing JSON. And so it's infinitely nestable. And that's what makes it so powerful, is that because it's infinitely hierarchical, we have infinite flexibility for how we want to organize our data, organize our APIs, organize our backends. So basically what it comes down to is don't worry about these fields, don't worry about any of that. I just want you to see, why is it intuitive to use JSON? What are the advantages? What are the disadvantages? Okay, are there any questions about that? This is also a different program. This is not curl. This is something else, which basically tells you everything you need to know about a request. And I will show you guys this next week at the first lecture, because it's pretty cool. Okay, if not, then I think what we'll do is I'll go over REST, and then if we have time, I'll introduce Postman. Otherwise, I'll cover it at the beginning of the next lecture, because I think it might go better there anyways. So REST. Okay. Actually, before I move on, are there any questions? Okay, I'll just let it sink in then. All right, REST. Before I go into the specifics of REST, the thing that I want you to really take away from this, really take away from REST, is that it's all about design. It is absolutely critical in software engineering. This is true at any company you go to. Smarter design leads to smarter products. It puts less work on you, less work on your boss, less work on the testers, less work on the user. Smarter design is what defines software. We design algorithms, we design computers, we design databases. Everything is about design. We design for efficiency, we design for effectiveness, we design for interoperability. REST is just our design principle for HTTP. So to go back to kind of what we mentioned earlier. So we have a set of given HTTP verbs, right? And we have a set of given fields that we can use, given locations, and a data center, right? That is actually much more flexible than you think it is. There are almost infinite number of possibilities that we can use an HTTP request to get what we want. And the reality is that while it's cool that we have so many possibilities, at the same time, if we were to utilize every single possible permutation of an HTTP use case, the internet would be completely splintered into just this weird jumble of millions of different design topographies. It'd be an absolute headache to navigate. It'd be very hard to create efficient softwares that can make the internet interoperable. It basically slow the internet down exponentially. So instead, we employ REST. And REST is basically a promise. It's a promise from you to the users of your website that you are going to follow these design principles. And because you're following these design principles, they can rely on you to send data a certain way, get data a certain way, and basically conduct yourself in a way that's conducive to interoperability, like to efficient software design, essentially. So there are 6 guiding principles of REST. and they are as follows. We have our client server topology. And basically, this means that we have our backend and we have our front end. And so we keep those things separate and we make requests between them in order to, number one, make sure data is secure and to make our requests more efficient. If, say, you had an app, a website, and like, I don't know, like a Tumblr or something, if you tried to write individual backends for each of those and then tried to have those backends communicate with each other, you would run into quite a few headaches. So instead, what we do is we store all of our data on one backend, and then we create multiple front ends that talk to the same backend. That's a much more efficient, effective solution, and it allows for much more use of that data across use cases. Okay, next is stateless. So each request from the client to the server contains all the information necessary to understand the request. So it's basically saying that for every request we make, the server can expect that it's all inclusive. So that way the server doesn't need to keep track of our previous requests. It can just rely on what we need now instead of worrying about keeping all of our data on the server side. So we have then cacheable, uniform interface, layered system, code on demand. These are kind of like important, but also like not as heavily emphasized REST principles. You're welcome to read about them, but really the ones that are important to understand is client server and stateless. These will play in quite heavily to how we are designing our servers. And I hope that it shows at least a little bit like a taste for why we choose to lay out things the way we do, because the reality is it's pretty arbitrary. Like software is very flexible. There's any one of a million ways we could solve a problem, but we choose one, and there should be a good reason behind that. And so here I'm giving you the reasoning, and next week you'll see how that manifests. Okay. You know what? Let's do this next week. That's fine. So before you guys go, I'm just going to preface next week. Today was incredibly boring. I'm very sorry about that. It's a lot of talking. It's a lot about design. It's a lot about protocols. It's definitely one of the more boring lectures that people have to sit through. I know that it made me grind my teeth when I was going through this course. It all boils down to, do you understand why we do things the way we do? And if you understand that, then you can understand how to design systems that leverage those specific design choices into more and more efficient websites and more effective user experiences. So next week is going to be a lot more hands-on. So we'll be building a server from scratch. We'll be building a database, and I'll show you how to communicate between them. I'll show you the testing frameworks. So next week, expect to dig into the code quite a bit. Before next week, I'll send you guys a list of things that you should come to class having set up. So it'll be a few technologies that we're going to need. And so if you need help installing those, try to go to office hours on Monday or Tuesday. But I will get that out so that you guys are prepared on Tuesday. Yeah, I think that's it. Also, a lot of times I do these lectures in Kresge. So if you guys are interested in sitting there at the same time, I'll probably be there next Tuesday during lecture time. So do with that information what you will, because technically lectures are online, but if you guys want to come sit and do it together, that would be cool. All right, aside from that, I have nothing else. Are there any questions? We still have like 5 minutes on the lecture. So if there are questions, feel free to stick around on the project. I'm happy to do like a mini office hours. But if not, you guys are free to go. Yeah, have a good day, guys.
Hi, I have, sorry, this is a basic question, but
Yeah,
is it okay if you go over what an API is? Is it just an interface that we can get and request data from?
yeah. So at the largest level, an API is basically a defined way in which you interact with a program. So let's say I design a software, right? And my software has this many functions or this many methods, right? And I give you my software. I can't expect you to go through my software and decide how to use it, right? Instead, it's smarter if I give you a list of functions that you can use and I tell you how to use them, right? That is the most fundamental definition of an API. It's a list of methods that you can apply to a software. So in the case of web development, an API is basically a list of methods that I'm telling you that you can access. So actually, I have an example API, which I'm going to cover next week. But this is an API for a web server that I designed for the course, like just a simple, stupid example one. But basically, it says like, okay, hold on a second. I'm just going to make this a little wider. It says, sorry, it basically says, okay, here are the locations to which you can make a request, and here are the types of requests you can make. So I obviously don't expect you to guess and check how to make requests, right? So an API is me communicating to you, here are the methods at your disposal. Please use them as you please. Here are the requirements, here are the parameters they take, here's the return value you can expect. So it's basically a top level way of saying my software is a black box. If you put in this input, this is the output you can expect. So if you make this request with this parameter, you can expect this response. And so that's kind of like the very, very top level of an API. And we'll go more into detail on exactly what an API is next week. Is that clear?
Yeah. So I guess if I were to use an example, let's say, for example, like PyTorch, it like
Yeah.
helps you make like, it makes the process of building like neural networks really simple.
Right.
So like, let's say if I want to look at the architecture of a model, there's like methods to do that. And that's is basically like an API.
Correct.
Right.
So if you've ever looked at like let's pull up PyTorch, right? So if you look at PyTorch, right? If we look at the docs, where are the docs? Oh gosh, hold on. Oh, here we go. Right. See, you see how this is called a PyTorch API, Python API, right? It's basically saying here are the functions that are available to you. Here is the return value you can expect for a given input, right?
Yep.
Does that make sense?
Okay. Okay, that sounds good. Yeah, thank you. Oh, also interested to see you in Kresge, right? Yeah, so
Yeah,
please.
yeah. I will be sitting like on the first floor in the very back. I
Okay.
call those like the stacks, and so I will try to be there. Okay, I'll send out it in the next Slack message. I'll let you know if I'm there, but
Okay.
I hopefully will be. So yeah, stop
Okay.
by.
Sounds
Mhm.
good. Thank you for the lecture.
Of course. Yeah. Have a good day.
Yep. Bye.